Hey everyone, and welcome to the second video from Chapter 1 for Math 244. This video is going to be about classifying differential equations. So this is going to be a pretty terminology, definition-heavy video, but this is kind of the basics that we need to be able to start talking about differential equations for the rest of the class. So we're going to talk about different ways we classify them here and go on to talk about other things in the rest of this section. So let's go ahead and jump right into that. So the first sort of classification that we're going to start out with is the difference between ordinary differential equations, partial differential equations, and systems of differential equations. So the first of these we're going to talk about are ordinary differential equations. And these are commonly abbreviated ODEs. And what this really means is that any function that we're looking for, any of the functions that we care about, only depend on one variable. So for instance, we could have a function y that depends on x, and it only depends on x. And from that, we can get a differential equation, say something that looks like this. And that gives us an ODE for this function y. It tells us how y and its derivatives relate to each other. And since y only depends on one unknown variable, named one dependent variable x, it is an ordinary differential equation. The second type of equation that you'll see are partial differential equations. And these are, as you could probably guess, commonly abbreviated PDEs. And these occur when you have a function that you're looking for that depends on more than one independent variable. So for instance, I could say something like the heat equation or the wave equation, both of which are PDEs. So in that sense, we have, say, a function u that depends on t, x, and y. And I can write a partial differential equation that relates some derivatives of u to each other. For instance, the heat equation looks something like this. As you can see in this equation, all the derivatives that I've written are partial derivatives, hence we have a partial differential equation, where in the first case, all the derivatives I wrote were ordinary derivatives, or normal just derivatives in like a Calc 1 sense, and that we call an ordinary differential equation. The last sort of thing that we use to classify them are systems of differential equations. And the main difference here between our things we talked about earlier and systems are that for systems we have more than one unknown function. So in the last case, we had our unknown function y, our unknown function u, but we only had one at a time. For systems, you have multiple unknown equations you're trying to solve for, and you have differential equations, equations involving derivatives, that relate all of them to each other. So one of these we talked about in the first video was the predator-prey model or Lotka-Volterra model, which I'll rewrite here, which is a system of differential equations because you have x derivative of x depending on both x and y, derivative of y depending on both x and y, and you want to solve these together to get one solution that solves both of them at the same time. So you're trying to solve a system of differential equations there. So that gives the three main classifications as a whole for differential equations. You have your ordinary differential equations, where your function only depends on one variable. You have your partial differential equations, so ordinary depends on one variable. Partial differential equations, where your function depends on more than one variable and your derivatives are now partial derivatives instead of just ordinary derivatives. And systems, where you have multiple equations you're trying to solve for, multiple functions you're trying to solve for, and a set of equations to try to solve those functions. So that's the first type of classification that we're talking about today, which is what type of differential equations do you have? Our second type of classification that we're going to talk about is that of the order of a differential equation. And the order of differential equations is pretty easy to determine. In this case, we're only talking about ordinary differential equations here. We're not talking about any partial derivatives. Systems can kind of go into the same lines, but mostly just a single ODE. And the order of a differential equation is just the highest number of derivatives that appears somewhere in the problem. So all I care about for order is the biggest number that appears as a derivative. So for instance, if I look at the following ODE for a function x, where I have the fourth derivative of x plus 3 times the first derivative squared equals 4t to the fourth, we see that the highest order of derivative that shows up is the fourth order derivative on the first term. So we would say this is a fourth order equation. Right, so this is not too hard to determine either. You're just looking at the derivatives that show up and what is the highest derivative that appears anywhere in the equation. So that's our second form of classification to sort of talk about. We have whether it's an ODE, a PD, or a system. We have what order the equation is. And our third and final one we're talking about today is whether or not an equation is linear or nonlinear. So what I really mean for equation to be linear or nonlinear is looking at if it's linear in terms of all of the unknown functions. So say we're looking at a PD in terms of x. So looking to solve for a function that's going to be x of t. Now, for the equation to be linear, I want that I don't have any x terms multiplied by each other, and I don't have x's in any weird functions. All I have is that x sits by itself or multiplied by a function of t. So for instance, if I look at the following ODE, this ODE looks pretty nasty. But if we look at all of the x terms, they all sit by themselves. I might have t in some weird functions or some nasty stuff, but the x's are all by themselves. X third derivative plus some function in t times x second derivative plus a function in t times the first derivative plus a function in t times x equals a function of t. No x shows in weird functions, no x multiplied by itself. So this is a linear equation. And quick check, what order is it? It's a third order equation. Now, what are we looking for if an equation is going to be not linear? So for instance, look at this following ODE. Now this ODE is nonlinear. How do we know it's nonlinear? We know it's nonlinear because we see an x prime squared term. So that is not linear in the x prime variable. It's squared, so it's not linear there. We also have an e to the x. Both of those are bad things. We have x embedded in either a squared function or an exponential function, both of which are not linear. So this is a nonlinear second order ODE. And finally, there are some other ways it can be nonlinear, so let's look at one of those. So this ODE, we again have two problems. The first of which is the sine term. So x being embedded in a sine is a bad thing. That's very nonlinear, so that's going to make it nonlinear to start. But we also have this second term, where we have x double prime times x prime. They're linear in each of them respectively, but since they're multiplied together, this is a nonlinear equation. Because if I take two different x's and put them together, say, I will end up with a product going on here. So if I have a product of mixed terms, even if they're different derivatives, it's still nonlinear for that reason. So this is a nonlinear third order ODE. And so those are the three main types of classification that we have for differential equations, whether or not they're ordinary, partial, or systems, what the order of an equation is, and whether they're linear or nonlinear. So that's it for the material for this video. At this point, I'm going to put up the video question for this video. So this is the question you're going to want to answer on your worksheet for this section and give it to me on the next day of class. So I'll put that up now. All right, so take a look at that, put that onto your worksheet, give all the answers on that, and then you can get to me the next day of class. All right, thanks for watching, and I will see you all in the next video.